thank you all for coming. I know there's many cool other talks. There is like this LLXT just happening. Many people went there, so thank you for being here. And welcome to my war story project and demo. Well, maybe not demo, but a demo in pictures of developing an art frame in Zephyr. So let's start with a small caveat. The presentation title, like the bio of the presentation, includes Bluetooth, LiPo batteries, and hanging the frame, but it was too chunky. Bluetooth didn't fit with Wi-Fi, and I decided a LiPo battery is not such a big thing, no point, right? And sorry to all wall mounting aficionados here, like no mounting as well. So what is covered? Basically, it follows a fairly standard schedule, agenda, so like motivation, some steps. I will introduce a small prototyping framework I designed, a little bit about LED handling, HTTP networking, and more about 3D printing and designing. Some hurdles, some solutions to them, and future work, of course. So who am I and what I'm doing here? I'm currently working as 5G chip developer. I do firmware for a silicon vendor. I tinker with Rust, Zephyr, game engines, and basically embedded Linux. After hours, I co-lead a startup of mine called Sticky Piston Studios, and I do some blogging as well. So if you'd like to see some of my hard work, then it's there. In my free time, doing sports, so going hiking tomorrow, I think. So yeah. Why do it? Mainly, I looked around my house that I just thought to myself, like, not enough art, not enough nice things. And then I thought, well, I can do some nice things. Like, I can design it, print it, program it, and I did it. And also, you know, most of you probably know that our job as, well, mostly embedded folks doesn't really, you can't really visibly see it unless you do, I don't know, some LED or a nuclear reactor or something. And then you see your work, yeah? Then you don't really, there is no place for mistakes. But with such a small, shiny project, you can easily prototype and see the effects of your hard work. There is also a cool project, like many cool projects, like the ZS keyboard, I think. I might have I remembered it wrong, or ZS watch, which really inspired me last year in Prague. Great project. If you didn't see it yet, then yeah. So how did I do it? Now is the time for the small framework of mine I devised. So basically, I divided it into steps. So step 0 is ideation. You find some inspirations on the web, go to conferences, talk to people. In my case, it was a fairly standard project like NeoPixels. And then you should choose the brain of the system. So either it is MCU, I don't know, maybe some PLC, maybe you need real-time requirements, so FPGA or ASIC, your choice. And once you've chosen it, you should validate it. So the earlier you validate, the sooner you'll get the answer, can I do this project, basically with, for example, Zephyr or some other system. And I will talk briefly about it in a moment. And start with a prototype. It's like even earlier than prototype. So in my case, it was a cardboard, as you can see on the picture. Then software minimum viable product, or prototype, I call it. So basically, you know what you can do. You design some fairly simple software functions or pieces, and you basically test them in isolation or together, your choice, on a breadboard or already using the prototype. Then hardware to put it all together, and that you can travel with it. I mean, I didn't travel with mine because it weighed a lot. And I think the border customs control wouldn't let me in with this. Anyway, software extensions, hardware assembly, basically, you can just add as many things as you want. But let me continue with the actual steps. So step 0, ideation. So as you can see, there are already a couple of shiny, cool projects similar to that. They have one thing in common, of course, they don't run Zephyr. Some of them are based on Raspberry Pi, the other one is using Teensy, and actually the one in the middle is being sold for $200. So, you know, maybe you could make a buck out of this project, right? It's an open source, open hardware, except for the parts I didn't design, so feel free to take it. And yeah, so one thing in common, no Zephyr, right? So when did it all start? Like, now is the time for choosing my board. And last year, I received a sample, this dev kit, ESP32C6, and I was very happy because it had RISC-V, and RISC-V is basically the cool thing right now. So I wanted to know more about it by, you know, immersing myself in it. But then it turned out it didn't have any support. So there have been some major changes with the hardware model version 2 recently released. So right now it's a mess. You can contribute if you want. There are links. You can follow this presentation on the web. So yeah, that's a small call for contribution, for participation. So yeah, I settled with good old ESP32, so Extensa. As you know, LED connectivity and programming it and flashing worked out of the box, right? It's Zephyr, it just works. With network, I had a little bit more of caveats. I will mention them just in a while. And there is, for astute watchers or readers, there is like the battery pack. Do you know where it might lead to? What kind of problem? Well, I will tell you in a moment. So, yes, step 1, validation. So it's basically assembling it, cardboard, having a LED strip, cutting it, assembling it, soldering it, and all should be fine, right? Well, it turns out that, like, on the right, you have what should be displayed. Maybe this slide is better. And on the left is what actually was displayed initially. So it turns out like I cut the strip and it was cut like in a snake manner. And I read the data like line by line, so I had to reverse it. Also, funny thing, I loaded RGBA images and tried to fit them into RGB buffer. So obviously it was total garbage. I fixed that and it suddenly started working fine. So then we validated it. We see that actually I can display something on it. Then probably, I thought to myself like, okay, either Wi-Fi or Bluetooth, I will try to send something to it using a some kind of application or web interface on my phone or on my desktop, be it. So yeah, this is basically how you handle, well, LED handling is just that simple. You just load the, you put the driver in, you put the device in the device tree, you get the alias from the device tree, you instantiate the device, and you check if it's ready, and then you load the data on it, and it works. Very simple. Networking is slightly more complex. It's basically like there is this small flowchart, I would say, of how it all works. So basically, we have a client that asks the server. They need to be connected to the same network, of course. Client asks the server, like, loads the website, server serves the website to the client, and then there are a couple of endpoints, I'll show them in a moment, that are that the client can call the host. And basically, once the image is loaded, so client does an API call to special endpoint, server does parsing of it, finds the magic number, which I added just for simplicity to know when the payload starts, and it raises a semaphore, and the image is displayed on the strips. So it's very extensible. I added some other APIs. It's basically that simple. I based it on two demos. Basically, it's one demo, but one is single thread and other is multi-threaded. I had to modify some code because it was very, very basic, I would say. Like, there was no handling of endpoints, there was no handling of multi-packets and everything. I will think if I will upstream it, I think it might be worth. I don't know yet, depending on you guys. So here is how I add endpoints. It's also fairly simple. And then there's some code. I won't go basically much into the details, but it's basically just string comparing the method type and telling which endpoint we chose. Then we basically do string comparisons of the API routes, and if we don't match any, then we return an error. Here you can see that since it's called multiple times, I needed to know the way if the header has been already read. So I added a static variable, which is later being set in the bottom part of the picture. So I found the magic number. I can now continue with reading the payload and loading the image data. So yeah, that's pretty simple. Up here, you can see I'm giving the semaphore, and the thread that's waiting on it is basically taking it and displaying the contents of the data to LED strip, basically. Some tips, because some things weren't really documented well. I didn't find some things. That's like that's a reminder to myself to put it in the documentation. Basically, I wasn't able to build the HTTP server example without adding this heap mempool region size. Otherwise, it would compare that I was overflowing sections. One weird thing, I don't know yet what's going on here, is basically I wanted to strip all IPv6 support, but it turned out if I stripped it all, Then I got some random crashes on every second HTTP request I made to the server. And I still managed to crash the server sometimes when I do the request too soon. I didn't debug it yet, but yeah, as you can see, it's a work in progress. And of course, make sure IPv4 address that you assign in the project conf is free, otherwise you just won't get a server running. So yeah, that's basically what is being served when you run the demo. And you can leverage JavaScript or any other browser runnable scripting language or any language on the client side to be called whenever you want to upload something to the server. Well, let's face it, this board is not a monster in terms of power, right? So I couldn't do any hard image processing on it, so I'm doing it on my laptop or phone. So yeah. This is the JavaScript code. It's basically very simple as well. You just draw to canvas, resize the image to 16 by 16. One thing I could do, it's very blurry, as you'll see in some images. I should probably run some edge detection, like sharpening filters on top of it. That's great because this is very powerful. It can run everything, right? And here you can see my previous bane, like this pixel data length I plus 4 and new index that is plus 3, just so I could extract the data properly. HTML is also very simple. Yeah, and this is the result. Basically, I don't know why the Rust logo is here, but it somehow made it. And this is very basic UI. It can also be tweaked as much as you want, as long as your browser supports it, right? Yeah, so this is... So let's come back to the battery pack. So several days pass, I've been using the battery pack to power the breadboard with the strip and basically the ESP32. And suddenly it started to go dim, and blue and red, blue was not at all visible, blue LED color, green so-so. And then I thought like, well, maybe I ruined something on the way, right? So I thought some color calibration issue, right? But then I looked online, I was like, no way. Maybe timing issues on the driver. I thought like, but the driver worked fine. I did nothing, I changed nothing. So as always, check your cables, check your battery pack. It turned out to drop from 5.2 volts to like 3-ish. So the red was actually powering on. It has like, yeah, that's right. It has 1.8. But the rest, yeah, they weren't working at all. So yeah. Let's now go through the hardware MVP. So basically, I didn't know any 3D design before. Like, I'm a software engineer by trade. So somebody once told me, don't learn FreeCAD. And I thought to myself, why? Then they told me it's difficult and counterintuitive. So yeah, guess what I did? I learned FreeCAD. So this is basically the design of the backplate. It's, yeah, basically the truth is that vanilla FreeCAD is lacking many features. I'm wondering sometimes how some of them have not been fixed for such a long time. So for example, there is this notorious topological naming problem, which basically prevents you from renaming nodes on the tree or reassigning the nodes. Like if you have a body that you shaped, you could, move some stuff around. It's parametrical and everything. But when you touch something that shouldn't be touched, you get errors like this. So this is the report view window, and it tells you recompute failed. Please check report view. It is the report view window. So yeah, thankfully, I mean, on the main branch, something like that, having been solved for such a long while, that's weird. But there is a fork from Real Thunder, and it works around this problem basically very well. It allows for disjoint bodies. That's one of the things that the original repo is lacking. And it has really good errors, so I can really know which vertex is not touching the other vertex, or like where's the problem. So yeah, I recommend it. This project was designed in like DIY spirit in mind, so composable and IKEA style hardware. So I printed everything. I then assembled it myself. No screws, no glue, almost. No glue actually in the final prototype. And this is like the BOM parts list. It's all available on my GitHub. Most of the stuff you can, basically everything except 3D printed parts you can buy. The rest you have to print or do, I don't know, out of wood or metal. So yeah, now let's go to 3D printing. I also didn't 3D print much before. I happen to have a Prusa. And 3D printing is usually not hard. I use PETG or PLA, and they should be fairly easy to use, unless the printer starts getting, not really, it's not doing well. So for example, I got spurious y-axis failures, I checked the belt tightness, I cleaned the bearings, and then I found out that Z offset was like ruined. Here's the picture, there is like a blob of something, there's a strip, like a pattern, and then there is some blob, it's basically ruined Z offset. I also happened to clog the nozzle. So that's the part that extrudes stuff. And I had to do the cold pull. So that's actually how it should look like. That's the blob of something, and that's like properly attached first layer. And that's, I don't know what happened here. That's the cold plug. So basically I heated up the Allen key, and then I put it into the extruder from above and had to cold pull like the rest of the filament. Sometimes when you fail to do that, for many times you just have to just buy a new nozzle, and that's not really costly, but it's a pain to assemble and disassemble the other way around. So that's the first layer being printed. The printer goes brrr. So some takeaways from 3D printing, if I may. So you will fail a lot, so print small slices, as small as possible, preferably full size, because it turns out that the print itself takes space. So like when the printer prints, it basically squishes a little bit to left and right. And this was the source, like for example, when you're doing holes or something, you should take that into account and add or subtract like 2 millimeters from each side, for example. So validate your assumptions. I happened to burn through entire 1 kilogram of filament, and half of it was basically to just make sure that everything clicks and sticks together. And bridges when the 3D printer has to go over a strip of air. So basically there's nothing below it and it just hangs a little bit, but it's fine at the end. So supports from PETG are terrible to remove. Don't bother. Like I managed to injure myself because I put a support under a bridge that was like 10 centimeters long. It was a pain. Anyway, the fun part, assembly. So basically, I just went through this to that to like the LED strip snake being there, my keyboard as well. And there is the breadboard still. And on the right, you can see like the clicked in strips. They're visible on the left. And basically, it was really satisfying because they all clicked together and it was like, you know, IKEA feeling. Then there is some test pattern being displayed. There is a PSU, which I'll tell you a little bit more in a moment. And there is the frame without edges. This is like basically, yeah, just assembly process. And about power. So I bought a very beefy PSU, 16 amps at 5 volts. And I measured then everything, and it turns out that at like full brightness of all LEDs, I only got 4.4 amps. But there is a graph here I blatantly copied from a website about this WS281B LEDs, and it told me that at full brightness it should consume 50 milliamps. Well, it didn't, but I ended up having a big PSU I can, you know, retrofit for something else. So software extensions, basically, yeah, as I said, I have some spurious networking crashes happening, I don't know why yet. I can add new endpoints and of course things I didn't add yet. So these are animations. I tried to add GIFs just before coming here. It turns out that, well, I would have to do it on the server side because JavaScript doesn't support it on client side in the browser API. I mean, I'll probably figure it out later. Automatic Wi-Fi connection and connection monitoring and restoring, maybe add a small, well, one more LED to show the status of the connection on the box. Persistent memory storage, so like having some samples to show around, or they could cycle automatically, maybe adding a remote, UI improvements, of course. Streaming games over Wi-Fi, it's like 16 by 16, but then I do some retro computing. So I thought to myself that maybe I could write some small and funny games on that, and using smaller PSU. So some takeaways. So check for your board. Well, check whether your board is supported as early as possible. Hack around and just try to prototype, just validate it as soon as possible. Contribute to Zephyr documentation. That's a note for me yet again. Of course, ask when in doubt. Like I had so much help in the Discord channel that I'm really grateful for, and people are, you know, replying almost instantaneously. That's really cool. Yeah, that's maybe obvious. Don't be afraid of new things, but we are all here, so you all like to learn. So don't listen to people on the internet. That's like one thing that's especially for me, especially with LED and people saying that FreeCAD is terrible. I don't know why. And yeah, 3D printing and designing are an iterative process, and you will fail a lot, and you will recalibrate your printer many times, and it will fail. Yeah. So as I said, some acknowledgements are due to folks from networking and Espressive channels on Discord, and folks from Espressive who are currently working on porting this ESP32C6 board and some other volunteers. So that's pretty cool. Further reading, actually, yeah, this is the fork. This is a cool printer calibration. It like really, well, it wasn't 5 minutes calibration for me, but it was like an hour, but still it was fun. Much better than the ones that are shipped with the printer. NeoPixels resource, that's also pretty good. It goes into the driver details. And a cool blog about RISC-V and Zephyr I just added on top of that. Yeah, so I happen to have written 2 blogs on that already. I plan to do 2 more, maybe even more, I don't know. And I added some repo links. And as I said at the very beginning, this is open source and open hardware where I could do it. I still have to learn PCB design and all the cool stuff. But yeah, feel free to remake it and showcase it. And I think we have come to an end. Any questions?
Do you have any video of this in no?
I happen to have them on my phone. I can show you in a while.
Okay.
Because
I'm just curious after the whole talk to see it because it animates, right? It's not only static.
Well, so I can animate it by sending new images right now. I wanted to add like the GIF support, but I failed so far, and I just didn't want to do it. I will add it soon.
Great. And yeah, actually, one other question, if there's no others. How did you settle on ESP? Actually, not. I know you wanted to use the C6, it wasn't supported, then you went to the 32. But out of, I know you wanted Wi-Fi, right? But,
yeah, I happened to have bought many years ago some like 10 of them in a pack. So then they were lying around. I was like, they're so cheap. I'll take one. If I burn it or do anything wrong, I have 9 more. So yeah, and there is actually a lot of support for drivers for the good old ESP32. So
right.
That's why.
Yeah, for sure. Yep.
I highly recommend you take a look at Fusion 360 by, what is it, Autodesk. It's free for non-commercial, and it's far better than FreeCAD.
Does it work on Linux?
Oh, okay.
See, that's like...
It works on Mac and Windows, so...
Yeah.
Okay.
Many people recommended me this. I actually did a little bit of modeling for my previous project in Fusion 360, but I did none in FreeCAD. So, but yeah, I'm using Linux, so that's the problem. Or maybe that's not the problem, right? That's like the advantage.
One more question from my side. You didn't mention the PCB I didn't see a PCB or how.
There is no PCB.
There's no PCB.
There's no PCB. It's all connected to pins of the ESP32.
Yeah.
There's a PSU. They share common power source.
Yeah, but then you have a development kit or it's a dev kit.
Yeah, right. It's like a ESP32 room, like the
Okay,
yeah.
I see.
Yeah.
Right, got it.
So, yeah. Once I learn PCB design, then I will surely showcase this.
I was just curious. Okay, thank you. All right, any more questions? No? Then an applause for Jakub, please.
Thank you.
Thank you.